Hello, everybody, and welcome to Sparing Partners. The topic of the day is the edge, the evolving role of the edge. Clearly, a lot of things happen at the edge, but this is changing because as we get more and more AI into the networks and in the RAN, how is the edge changing? And also because networks are their task is evolving as well. So um, I am very lucky to have here an expert of all sorts of things, but also an expert, especially an expert on the edge, and all the issues that are related to edge versus the centralized cloud. And that's Manish Singh. And he is the global CTO of telecoms at Dell. And I've known Manish for a very long time since he first was at Continuous Computing. Is like a beautiful name for a company. And then Radis's Meta, and I'm forgetting, I'm sure others. And he is now working at Dell, deciding their strategy and all that. So it's a really impressive role that Manish has this day. So Manish, welcome to Sparing Partners.
Thank you. Thank you for having me. Pleasure to be here.
So I already said something about you, but maybe you can introduce yourself to the audience, and then we'll plunge in.
Yeah, as Monica, you said, known you for a long time. You took me back down the memory lane with continuous computing. Partly, largely my background has been telecom, and within telecom, largely mobile networks. When you said continuous computing, rather, I remember back then our discussions used to be around small cells, actually, even before that on femto cells, and then all things LTE and voice over LTE, and so on and so forth. And that journey continued into Radisys with a lot of the voice over LTE and DPI solutions as the traffic on the mobile networks was exploding. So that, and then Meta with the Meta glasses and all of the things that Meta was thinking about. But broadly speaking, have been in the industry for a while. I don't want to date myself necessarily, but been around the block and mostly focused on mobile networks. Rather, timing had it. I was just sharing with one of my colleagues. Just coming back from Mobile World Congress, and I was thinking about I've been at that event since it used to be 3GSM in Cannes, and since then, every year except two during COVID, have been at Mobile World Congress one way or the other. So, it's been a great journey, being part of the mobile networks and evolution of the mobile technology, and obviously along the way got to know you as well, and great to be here.
Yeah, absolutely. And sometimes we forget, but if you think about what happened over the last, say, 30 years, there's not that many sectors in the economy that can boast that much of a change in terms of the society. And maybe not all of it is good, but 90% is, I think. I mean, it's just like if you think about, how could we possibly live without a cell phone? I don't know.
Oh, I am telling you, I was again thinking about this a bit. Back in the 3GSM con days, that used to be the days of GSM and GPRS was on the horizon, and the talk of the town would be flip phone and slide phone and new phone launches and whatnot. And then pre 2007, this was the world of 3G, and the spectrum auctions in Europe had happened. All the operators had to build the networks, acquire spectrum, and everybody was screaming, "Where are the mobile devices?" And came 2007, the iPhone moment, the new device appeared on the scene, and did that change the world forever as we entered into the smartphone era? And then LTE, I think, almost had a latent market demand, and we were all scrambling to build the 4G LTE networks and on and on. But yeah, to your point, what a what a fascinating journey, an industry moving from 3G, 4G, 5G, not to forget all those little advanced in between 4G advanced
Yeah.
and LTE advanced and now 5G advanced and more. But yeah, I mean, it's the industry has been constantly innovating and reinventing itself along the way.
And now we are on the cusp of a new transformation, I think, with the AI. So we're not going to talk specifically about AI today, but talk about the edge. And maybe you can give us sort of like your impression, because while there is obviously a lot of centralized, a lot of a lot of the AI stuff, it needs to happen in data centers and all that, but the edge is so. I guess that what the edge reminds us that in this whole thing, physical structure, location really still matters a lot. It's not, so the fact that we can do a lot of things in a centralized fashion doesn't mean it's the best way to do it. And we need to look at the trade-offs. And so maybe you can give us your perspective on what is the edge and how is changing.
Yeah. And I would say even before AI, the edge has
Mhm.
been
Yeah.
continuously taking shape. It's a broad word. It's a word that gets sometimes overloaded. But when I think about edge, it's things outside the data center. You have near edge, far edge, you have enterprise edge, you have the telco edge, as in the network edge. So it's sort of a continuum where you tend to think about across that continuum, uh, where do I need the compute resources and why? And there are multiple factors that come into play. You can start to think about the problem space from a security standpoint, as in how secure and what kind of security paradigms do I need out there. You can start to think about from a latency perspective. Sorry. You can start to think about it from a latency perspective, going back to your point around physics. So, implications around latency sensitivity. You can start to think about it from a data gravity perspective, because where is the data? Where is the data going to originate and get generated? And as we all know, data has got gravity. So, from a data gravity perspective, and that starts to define this edge continuum, as I would call it, where can I best place the workload? If I think about it from a workload perspective, workloads have a nature of finding the best landing location, be it in the cloud, be it in the data center, be it on the edge, near edge or far, the best location that they can land to meet the requirements that they want to serve and meet, which could be latency, security, data gravity, data privacy, and a combination thereof. And that's why this space gets complicated, because it's not just one size fits all. And so we do see a lot of solutions going on-prem in the enterprise edge. We do solutions landing on the network edge and in the continuum across that those edge locations. And this is only going to continue to become even more relevant and important, in my view, as AI starts to get more proliferated and inferencing starts to become more important. And we can talk a little bit about even newer scenarios and use cases that I'm seeing around things like physical AI and all. But the meta point being, edge is going to take even more shape because of where the data is and also constraints around things like latency, security, and more.
And I think that what you're saying points out to an important factor is that, in the past, what was at the edge, you had to put it in the edge, there was no option. Now, technology allows you to put the same things at the edge or in a centralized location. So the question is, as you put it, is what is that you need? Well, and I would say also what is that you have in terms of transport, real estate, and ability to secure the location. So there's all sorts of things that happen, and then there's things like latency that are not going away anytime soon. But within that, we have the technology to choose. which is a new thing. So the question is, how should we go about it? And so, how should we approach the decision given that? And it's not a question just of cost or just latency. It's the whole these constraints that interact with each other. So how do we go about
Yeah.
deciding what's best?
Deciding what's best, in my experience, what I've seen, it starts with what's the problem you're trying to solve, sometimes talked about as use cases. What the problem that you're trying to solve, uh, with that comes a certain set of attributes in terms of to solve that problem. Uh, what kind of data do I need? What kind of latency requirements do I have? What kind of security requirements I have? By the way, within data privacy, sovereignty, all those other elements come into the mix. And what I would also add is you have your IT domains and you have your operational technologies. And in many cases of the OT domains are the ones that will require have more need for edge, where you need to bring the compute and going forward the AI more closer to the data source because a lot of those operational technologies will be generating data, will be requiring compute capabilities for the operations that they want to perform. So instead of being so abstract, if we make it a little bit more real, think about manufacturing inside inside a factory plant where you've got all different kinds of operational technologies that are working on. And they do need to require computing resources. Oh, by the way, they're generating a lot of data. And going forward, we need to unlock the value of that data with AI. So becomes a perfect example of bringing compute closer to the data source, i.e. edge. Think healthcare as an example, where you have all again different operational technologies, X-ray machines, MRIs, on and on. I mean, patient monitoring, all of that. These are all operational technologies. Again, they require compute. Latency, security starts to become super important. Oh, by the way, a lot of these operational technologies are generating data that we need to again unlock the value of it, need to bring more AI centric capabilities. And so you can start to see the picture emerge that edge starts to take shape around the use cases, the operational technologies, the requirements that they place. And that's how Edge has evolved and continues to evolve. I mean, we can take even more examples. Retail, completely different environment where you're looking at customer footfall, customer preferences, customers doing a product search, going through product catalogs back in the day. Now that's all going to change. And I mean, we now already are working with a number of customers who are actually deploying, believe me or not, looking at putting chat agents out there where you can just go and put your question in natural language and it'll do all the back end work on the product catalog and come and start to serve options to you. So again, enhancing that customer experience on and on. So yeah, just to sum it up, we can talk more, but whether you look at manufacturing, retail, healthcare, on and on, it's the edge starts to become important from enabling again all those operational use cases that are out there driven by latency, sovereignty, data security, all those paradigms, taking them into consideration, and solving for the actual business problems that each of those industry verticals are looking to solve for.
How do we think about it in terms of sustainability and power efficiency, edge versus central, and the ability to basically do pooling, and so you can use resources more efficiently if everything is centralized because you just you know direct wherever you need the resources, which is harder to do if the stuff is at the edge. But then in a way, the sustainability, I mean, you might need less power because you don't need the transport. I mean, everything is there, or maybe not. So, how should we think about those trade-offs?
Yeah, it's a great question you ask. One of the one of the characteristics we haven't talked about of the edge is an edge is not a data center. And what I mean by that is it's a harsh environment. So if you think from an edge location perspective, space, power, cooling, all of these become constraints in that environment. You have limited space, you have limited power capabilities, you have limited cooling capabilities, on and on. And so the the typical compute platforms that would meet the data center requirements are not necessarily the platforms that can always meet the edge requirements. And the second thing is in addition to, and I'll come back to the power and sustainability aspect of it, but just even broadening the lens, in addition to deploying the compute in the edge locations, we also need to think about the lifecycle management because it is one thing to deploy 1,000, servers and manage them in a data center. It's a different problem space to deploy one server in 1,000 locations and operate and manage them. It's a completely different paradigm from a lifecycle automation perspective of how do we do that. So it does require a lot of automation first mindset that when you think about edge, otherwise the problem becomes intractable very quickly as you start to scale. The second part I would say is, from a power energy efficiency perspective, super, super critical that we have solutions that are designed grounds up for the edge locations, can support things like extended temperature range, does not require massive amount of cooling infrastructure. Because even if you require, you might not actually find it on that manufacturing floor or in that retail store, might require much lesser space from that perspective. And I'll just share with you since I just came back from Mobile World Congress. I don't want to talk too much about products, but just to give your audience a sample, one of the solutions, XR9700, the number is not important, but this was something that we were showing at Mobile World Congress, which is an outdoor compute unit. Now, if you since you come from the mobile world, you're familiar with the radio unit, right? And if you think about a radio, what does it look like? You got a bunch of radio hardware sitting in there, but wrapped in a massive heat sink. Well, this is compute wrapped in a massive heat sink, and it's 15 liters. One person can take it, go deploy it on a pole, can deploy it on a wall in an outdoor environment, does not require its closed loop liquid cooling, operates in extended temperature range, and IP66 compliant from an environmental perspective, so can really be deployed in harsher environments. The meta point is that when we think about edge and think about bringing compute closer to the OT and the data source, to bring AI closer to the data source. When we think about that, we need to think about how are we going to, meet all these power cooling, space, and lifecycle management around these around these edge devices. That becomes really, really important. And the other thing I would say from a power perspective, since you touched on that, a lot of these systems are literally either fanless or liquid cool now. I mean, as I just shared the closed loop liquid cooling solution that we're doing. So that all adds up towards the energy efficiency and improvement of that. And then, of course, there are multiple knobs in the compute platform as well. You can turn things up and turn things down in terms of clocking the CPUs all the way down to the physical fans and everything in there, depending on what the workloads are and when they need massive amount of compute capacity or not. So all those knobs are, obviously we've been working to make them available, to make these platforms highly energy efficient. And again, to your point, continue to drive towards that goal of sustainability.
And I guess, as you mentioned with the outdoor unit, we have more form factors because it's one thing when you are outside in the desert or you are in Seattle, which is where I used to live. So it's completely different weather. situation, if you're in the city, if you are in a place where you need more protection, or if you are indoor in a retail mall or in a manufacturing floor. So I think that if you have more form factors available, then it's easier to if you're deploying a network to decide what goes where, and you find things that meet your requirements, which in the past, again, it wasn't like that.
Yeah, it wasn't like that because again, as I said, Edge has been this nebulous thing, which has continued to evolve and continue to evolve because going back to the use cases and where's the data and all of that. So it's continued to evolve. But yeah, to your point, requires different form factors. Requires the other thing that's important is it's not one size fits all. It's not like, oh, one liquid cool wall mounted compute fits all the use cases. No, there are going to be use cases that need that. There will be use cases that require more scaling. And so you might have to go into sled-based designs and have more optionality to scale things up or down. Depends on, again, use cases, compute requirements in there, and none of those are static in nature and continue to grow. So that to your point is another key consideration. Yeah.
And then I guess it's also an argument, implicit argument for openness, because then again, you need to have different things in different places, but that also increases the complexity. But that's where I would imagine AI comes in terms of helping you taming the complexity or making it manageable, because obviously you cannot have all the because all the settings are going to be different depending on where you are and what are your requirements. So power efficiency is going to be managed differently if you are an outdoor unit or indoor or whatever, whatever the case may be. So how is AI going to make it easier to manage the edge?
Yeah, I think, I mean, the way to think about from an AI perspective is AI in and AI on. There's going to be AI in the edge, which is going to play a key role in all things that you're kind of touching on. How do I take all the data that's getting generated in here on whatever that use cases might be and the data sources might be? How do I take all of that into account and make the decisions? And those decisions could be as much as from a power and energy efficiency perspective to improving whatever use case you're working on, their performance perspective, and more. But I think there's this other vector with AI that's continuing to come up, which is around AI inferencing, which is what I would call as AI on the edge. And this is where I think there is a new class of AI use cases that are really starting to come up. These are not your large language model chat bots or chat agents that I'm talking about, but things next. I'm thinking about things like physical AI or things like connected glasses, but that requires a lot more contextual AI support. In those cases, we need to bring inferencing further out, closer to where the device is. And when we think about bringing inferencing further closer out, it could be a mobile network edge or other locations where we will need these capabilities. Two examples, I would say, physical AI. That's a world, as the word says, it's physics bound. So time and space matters, latency dramatically matters in that realm. And so edge starts to become this very priceless real estate that the telcos have or whoever has that they can bring in to really unlock the the whole physical AI paradigm. And physical AI broad sense everything from your driverless car to the robotics and everything that's getting that's up and coming. I think though there are a set of use cases where edge is going to play a key role in enabling bringing AI closer to that where latency and physics is really important. The other one I would say is like like these AR glasses, right? Which we see, now number of these coming up. But here's the constraint, right? These glasses are uh, very constrained in terms of power, cooling, battery life. And so you can't put a lot of compute on the glass, i.e., these glasses need assist. And not to forget, they need a lot of context, audio, video. The more context they get, the better user experience they can generate. So when you have limited compute, but need for a lot more context, you need assist. And I think again that edge starts to become a great location to provide that assist. Of course, it has other implications in terms of uplink bandwidth as well that will be required. But I see the potential for edge really coming into shape with these kind of use cases, be it on physical, be it on AR kind of glasses, where you bring again AI closer to the data source and really unlocking and meeting the constraints and requirements that these use cases will have.
And I think it's interesting, but also we should keep in mind that you can train the original model in a data center and then push. So because sometimes people just think that everything happens in the edge, and obviously that doesn't make any sense because when you need to have massive amount computational power, you need to be in the data center for the basics, and then you kind of do the inferencing and the what is local stays local, sort of. I mean, sort of as a very general
Well, I
issue.
completely agree with you. I think, the way to think about it is fairly straightforward, right? I mean, you have large training clusters, large training clusters where you are actually taking large amount of data and actually training your models, fine-tuning them. That's happening inside these massive data centers with the training clusters. Inference, on the other hand, is where you take these trained models and you're actually applying the real world data to it to infer the outcomes, right? And that will happen more and more on the edge. And by the way, that edge, as I said, is a continuum in the world of mobile networks. Your edge will go as far as your mobile device. You will have certain inferencing even happening on your mobile device to AI PCs, to edge locations, to core networks, to cloud. It's going to be a continuum because AI is the foundational technology and it's going to make its way everywhere. So, across that continuum, edge is where, as I said, a lot more inferencing is going to happen. The other thing, since you touched on training, that might be worth touching on is opportunities around federated learning. And what that is, and this has been a paradigm that has been out there for a while, you're not doing massive training at all, but opportunistically, you can do some learning across different edge nodes and consolidate the weights. And there is a good bit of math. We don't need to probably get into that here, but there's a good bit of math involved in it to say that's how we can do it, and we can learn from data in different edge locations, bring it together, and generate a bigger model that takes into account all different data sets that it came across, different edge locations as well. So federated learning probably, I think, will happen a little bit on the edge, but not training and inferencing a lot more, for sure.
And also you can learn from the edge as
Yes, of
said,
course.
which is also an interesting. It's not everything sort of goes into all sorts of direction and can be in different places. You decide what you need. However, when it's all said and done, the compute requirements at the edge are going to increase, right? So how much is that, and does that mean that we need a GPU everywhere in the edge?
I think when it comes to AI, right, I think there is this it's a continuum, right? I mean, there in that sense, there are use cases that can very well be done on the CPUs itself, especially from an inferencing perspective. We actually see a number of our partners that we are working with who have a number of use cases. I mean, video analytics, a lot of those video-based use cases we already today are doing on CPUs today. And then, of course, as you start to scale things up and you're getting into larger models and more complex data sets, in that case, you might require GPU. And oh, by the way, it's not one size GPU. GPU themselves come in variations, so you can end up with a much smaller GPU to then even a need for larger GPUs. I think the one thing I would say for your audience to always keep in mind is we can always throw the largest GPU at the problem, but recognize that edge is a constraint location. Power, space, cooling are all constraints in an edge location, not to forget cost. So, what's the right compute platform, a CPU, a GPU, or a combination thereof, is going to be governed by what's the use case, how much space, power, cooling is available, and what's the cost dynamics in terms of total cost of ownership and the business impact that can be landed. I think those all come into the mix to decide what the right platform would be.
Yes, and again, we're going to see, to say it's not one, it's not one, or it's not a Boolean thing. You have it or you don't have it. It depends on what is that you need, how much you need, and you go from there.
Definitely,
Yeah,
definitely.
yeah. Okay, our time is pretty much up, but before I let you go, I'd like to ask you, what do you see the evolution of the role of the edge in the next few years? To the extent that we can see, because it's becoming the future. Used to be able to look at 10 years from now. I don't think we can look at 10 years from now, but how do you see the role of the edge changing?
But the role of the edge is going to continue to grow. That's how I see it. As more and more technology proliferates out and about into the physical world. I mean, I even just very briefly touched on physical AI or AR glasses, and there are many other such instances. So, as these technologies, whether in the consumer paradigm or in the business paradigm, think manufacturing, healthcare, retail, etc., as more and more OTs come in. Simple example, think about people talk about warehouses and now a lot of AGVs and everything getting deployed in there. These are all evolutions of those spaces, an evolution of the retail environment or a warehouse or a healthcare medical facility, whatnot. Technology continues to proliferate in each of these environments. As that proliferates, generates more data, demands more compute. And so my view is that edge is going to continue to grow, and we will need more compute, more AI proliferate across the board. On the AI side, not so much for training, but a lot more for inferencing, but we will continue to see this grow over time. And it will never be one size fits all. Edge will also have its constraints. And so this is where the nuance comes in. Identify what the use case, the problem we are trying to solve, the data sources, the constraints that the edge are, and accordingly find the right solution in terms of the compute platform that needs to be, brought to bear.
Yeah, actually, when you think about communication, puts us in contact with everybody far away, but also puts us in a better content, a better opportunity to understand our immediate environment. Which I guess what the compute at the edge does is to make sure we can actually, well, say, control or use everything that the connectivity gives us to about the local location, which is very important.
Yes, that's it.
Thank you so much for sharing your thoughts with us. It's always inspiring to think about it, to talk to you, and to think about all those issues. You have a unique perspective on this. So thank you so much for sharing your thoughts with us today.
Monica, thank you very much for having me. Absolutely a pleasure talking to you today. Thank you.
Thank you.